Here's 1123 from the motion worksheet this week. We're going to look at part B. So we've got a car moving along the freeway according to the given equation where x meters is the directed distance of the car from the given point P, t hours. Find the values of t for which the acceleration is 0, and then find the position of the car at that time. In part B, we have x equals negative 3t minus 1/12 negative 3 root t minus 1 over 12 root t for all t positive. First up, I'm going to rewrite the equation for the position. So I'm going to write it as negative 3 t to the 1/2 power minus 1/12 t to the negative 1/2 power. And we can do that because a root t in the denominator is the same as a t to the 1/2 in the denominator, which bumped up would be t to the negative 1/2. So let's get to the velocity first, and then we'll go into acceleration after that. So velocity is first derivative of position. So this will be negative 3/2 t to the negative 1/2. And then plus 1/24 t to the negative 3/2. So we have velocity now. Let's take a look at acceleration. For acceleration, we're going to take the negative 1/2 and multiply it by the negative 3/2 and get 3/4. And then that's going to be a t to the negative 3/2 power. Then we're going to take our negative 3/2 and multiply that by 1/24. So that's going to be, let's see, 3 and 24 will cancel into an 8. So I think that's negative 1/16. And now that's t to the power of negative 5/2. And we'd like to know the values where the acceleration is 0. So we want to set this equal to 0 and go about solving. So first thing we want to do here is rewrite this without negative exponents. So I have 3 over 4 t to the power of 3/2 minus 1 over 16 t to the power of 5/2. And it seems to me like the common denominator is 16 t to the 5/2. So that means the 4 t to the 3/2 needs multiplied by a 4 and a t, because we have, let's see, a t to the first times t to the 3/2 will be t to the 5/2. That works. We'll multiply the numerator by 4t as well. This is still equal to 0. And that gives me now a 12t minus 1 over that common denominator of 16t to the 5/2. We still want to know where the acceleration is 0, so 12t minus 1 equals 0 implies that this happens when time is equal to 1/12. So we have our answer there for the first part. Then find the position of the car at that time. So to do that, we want to take x of 1/12 and plug that in. So 1/4 times a 1/12 to the 4th plus a 1/6 times a 1/12 to the 3rd minus a 1/12 squared plus 1. I'm going to leave that to you, the calculus student, because I don't have my calculator pulled up right now, and I would definitely be using my calculator for that. That finishes everything here on 1123B.